Hello, this is a lesson on simplifying polynomials. So we'll start with what is a polynomial. This is the general form of a polynomial, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus dot, 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 that means the pattern continues, plus a sub 1x plus a sub o. And polynomials are made up of terms. And terms are separated by an addition sign, a subtraction sign, equal sign, or an inequality sign. So each of these is a term. And the numbers in the front, a sub o, a sub 1, a sub n minus 1, a sub n, those are called the coefficients of the polynomial. And we like to write polynomials in descending order. And so that's what's going on with this x to the n and x to the n minus 1. Descending order refers to the order of the powers. So, for example, this polynomial, 3x to the 5th plus 6x to the 4th minus 2x cubed plus x squared plus 7x minus 6 is in descending order because x to the 5th, x to the 4th, x cubed, x squared, x, and then x to the 0 for that constant. The coefficients are 3 and 6 and negative 2, and there's an understood 1 right here. That's always a good idea to write it in when you're doing calculations. And then there's a 7 and there's a negative 6. Now, since negative 6 doesn't have a variable with it, we call that a constant term. Okay, now the reason we like to write our polynomials in descending order is because when you've got a polynomial and it's all multiplied out and you've got terms that are separated by addition, subtraction, the leading term is the term that has the highest exponent. So 3x to the 5th is called the leading term. And the 3 is called the leading coefficient. And we'll learn about this later, but this degree, the degree of the polynomial is the highest degree, and that tells you a lot about the behavior. That's what we'll learn later. So this is a degree 5 polynomial. Okay. The next thing is we need to learn just some quick exponent rules. There's a lot more exponent rules, but we'll just learn these first two because these are really important to keep separated out and understand the difference. So x to the m times x to the n, when you have this x is called the base, and it has an exponent of m, times same base, x to the n, you actually add the exponents. Okay, so I call that the same base rule. So if we have x to the 5th times x to the 3rd, that would be x to the 8th. I call it the same base rule. And the reason it works, if you want to look at it, so x to the 5th, that means x times x times x times x. So exponents are just repeated multiplication times x times x times x. And then if you count up the number of x's that are multiplied together, a shortcut way of writing that is with the exponent, because the exponent is repeated multiplication. So you have x to the 8th. So that's why you add when you see the same base. So I call that the same base rule. So if I see something that has like p to the 4th times p to the 8th, that's the same base multiplied together, so that's p to the 12th. Okay, that's different than this rule where you don't see the same base, but you do see two exponents. X to the m to the nth power, that's when you multiply the exponents together. So if you had x cubed to the 4th power, that would be x to the 12th. Okay, so you really have to know when you multiply exponents together and when you add them. Okay, now let's talk about adding polynomial expressions. We must only add like terms or subtract like terms, or but we'll get to subtraction. So what is a like term? Well, like terms have the same variables to the same power. Okay, so what we mean is 4x cubed and negative 2x cubed. Those are like terms because they have the same variable to the same power. Okay, but 3x to the fifth and 2x squared, they are not like terms. Okay, so we have to know what like terms are because we can only add or subtract like terms. Okay, the other thing that we'll start right now to talk about is sometimes students get confused about what to do when we see an expression. Okay, so you've got to know that word, an expression. An expression does not have an equal to sign or an inequality sign. Okay, so we don't solve expressions, we simplify them. So sometimes students will try to solve an expression. Well, no, you just simplify them. And so what that means is you just collect like terms. Okay, so simplifying means to collect like terms in this example. Okay, so if I say simplify this polynomial, parentheses x squared plus x plus 5, that's a polynomial, called a trinomial, because there's 3 terms, plus 3x squared minus 10x plus 4, that's also a trinomial, 3 terms. And so you might notice the parentheses. Well, if there's nothing in front of the parentheses, or if there's only an understood 1 in the parentheses, then those parentheses are not really needed. But if there is something in front of the parentheses, even like a minus, then you have to distribute it. So you have to know when the parentheses are important or not. In this case, it's just grouping it so that you see you're adding a trinomial plus a trinomial. So I'm not going to deal with the parentheses. There's nothing to deal with. So I'm going to put this understood 1 here and this understood 1 here, and then now it's time to add like terms. So we have 1x squared plus 3x squared. This is not an equation, so sometimes people do that. See, I like to do what people do wrong. Sometimes that's not right. You don't have an equation, right? So you don't do that. All you do is simplify, and I like to say it's like they shake hands. 1x squared plus 3x squared becomes 4x squared. So when you add like terms, you add the coefficients, but you don't add the power. And then we have another pair of like terms, 1x plus a minus 10x. So that would be negative 9x. And if you need your calculator, you can use it at any time. So we have 1 minus 10 equals negative 9. All right, and then we have another set of like terms, 5 plus 4. So that's positive 9. So this polynomial plus that polynomial gives you 4x squared minus 9x plus 9. Okay, try this one. All right, negative 6x squared plus 3x squared. So negative 6 plus 3, the signs are different, so you subtract. So that's negative 3x squared. And then 7x plus understood 1x is 8x. And then 3 plus 3 is 6. And that's it. We are done simplifying because they aren't like terms anymore. Okay, now if you're subtracting polynomials, then the main thing that happens is students sometimes forget to distribute the negative to all the terms. So I do that first. I distribute the negative first by remembering that subtraction is really just adding the opposite. So my method is when I see a trinomial or polynomial minus a polynomial, see that minus is in front of that parentheses. So here, the parentheses here are very important because that minus doesn't just belong to the 5x squared. That minus belongs to all three of those terms. So I'm going to rewrite this as 3x squared plus 2x minus 2. There was nothing in front of the parentheses. I'm going to drop the parentheses. And here I go. I'm going to change subtraction to adding the opposite. This is me distributing the negative. So I'm going to change this minus to a positive, but make that 5x a negative 5x squared. And the opposite of minus 5x is positive 5x. And the opposite of positive 6 is minus 6. So what I just did was change subtraction to adding the opposite. And now that I've dealt with that, now I'm just going to do what I did over there. So I can always change subtraction to adding if I remember to add the opposite. So now I have 3x squared plus a negative 5x squared is a negative 2x squared. And then 2x plus 5x is 7x. And then negative 2 plus a negative 6 is a negative 8. So negative 2 minus 6 is the same as negative 2 plus a negative 6. And when the signs are the same, you add. Okay. So 2 plus 6 is 8, but you keep the sign. So that's negative 8. All right, so you could try that one. All right, I'm going to rewrite this as 5y squared minus 1y plus 2. No negative in the front of that parentheses, but I'm going to distribute that negative, change that to adding the opposites. The opposite of negative 2y cubed is positive 2y cubed. The opposite of positive 3y is negative 3y. And the opposite of negative 3 is positive 3. So I've distributed the negative. All right, now this one, you have to pay attention to the exponents because these are not like terms. And we like to write it in descending order. So you might have noticed I've been crossing things out. This is when it gets helpful to cross things out. So I want to look for the highest term, the highest exponent. 2y cubed doesn't have any like terms, so I'm just going to write it first, cross it out. And then there's a 5y squared. It doesn't have any like terms. I'm going to write it down. It's plus 5y squared. And then finally, we've got some like terms. We have a negative 1y and negative 3y. That's minus 4y. And then we have 2 plus 3, and that's 5. So we subtracted by changing this to adding the opposite, and then we added like terms. Okay, so I would practice these. Hit pause, practice them, and when you unpause, you'll see the key. Okay, how did you choose? We have the answers here, so check over them. And I just wanted to make a note here. You can leave the understood one in your final answer, or you don't have to have it. And then on number 4, did you know how to handle this? These two are like terms. So that would be minus 4xy. All right, let's move on to multiplying polynomial expressions. And so the way that we do that is we have to know the distributive property. Okay, so the distributive property is called the distributive property for multiplication over addition, or the distributive property for multiplication over subtraction. So it looks like this. If you have a number outside parentheses where two terms are added together, then you distribute that a to both of them. So that's ab plus ac. Can't forget that that a belongs to the c as much as it belongs to the b. And the distributive property for multiplication over subtraction looks like that. And so that would be AB minus AC. And I think it's important to know the name of it because there's no distributive property for multiplication over multiplication. It's over addition or subtraction. So in order to do this, you have to remember these exponent rules that we learned on the front page, which is, remember this, x to the m plus, times x to the n is x to the m plus n. So when you multiply this 6v times this 2v, that's 6v to the 1 times 2v to the 1. So 6 times 2, you multiply that just like regular numbers, that's 12. But v to the 1 times v to the 1, you're adding 1 plus 1, that's v squared. And then when you distribute this 6v to the 3, that's 6 times 3, that's 18v, because there's no v there multiplied. And anytime you write a term, remember there's got to be a plus or a minus in between, except for the first one. So that's why I would put that plus there. 6v times 3 is positive 18v. All right, so this one, when you distribute, you've got 3 terms to multiply that negative 3x with. So that's negative 3x to the 1. So that would be negative 12x cubed, because a negative 3 times a positive 4 is a negative 12. When you're multiplying a negative times a positive, it's negative. But here, negative 3x times a negative 6x, that's positive, because a negative times a negative is a positive. That's 18. X to the 1 times x to the 1 is x to the 2. And then negative 3x times 5, that's negative 15x. Okay, so now that we've talked about the distributive property, let's talk about multiplying binomials. That's 2 terms. You may remember FOIL, F-O-I-L, but I like to think of it as double distributing. And I'll tell you why in a minute. But you can think of FOIL. You can multiply the first terms, and then multiply the outer terms, and then multiply the inner terms, and then multiply the last terms. But I don't really think about FOIL until it's time to go the other direction, or when it's time to factor. So I'm just going to double distribute. Okay, so what that looks like is, if you have this binomial times another binomial, then this 2x needs to be multiplied to both of those terms. So that would give me 2x times 5x is 10x squared. And then 2x times 4 gives me the term positive 8x. All right, well then I have to also distribute this minus 3. So when you see the minus in between 2 terms, it's a minus, but when you think of just that number, that's a negative 3. So you need to distribute that negative 3 to both of those. So negative 3 times 5x is negative 15x. So, but when I write it down, it's a minus when it's in between 2. So that acts like a minus and a negative. That's a negative 15, but it's 8x minus 15x. Okay, and then negative 3 times 4, that's negative 12. Okay, now what do you notice? When you're multiplying binomials that have the same variables in them, you will often have like terms, and it will often be those 2 terms in the middle there, the outer and the inner if you're thinking FOIL. So we have to add those. So 10x squared, 8x minus 15x is minus 7x, and then the minus 12. Okay, so try this one. You can pause it and try it. If you do it correctly, you're thinking double distribute. 8p times 3p is 24p squared. 8p times a negative 2 is negative 16p. Negative 5 times 3p is negative 15p. Negative 5 times a negative 2 is positive 10. The like terms show up in the middle. 24p squared minus 31p plus 10. Okay. So just a major point here, there is no distributive property for exponents over addition. What I mean is, this is a very common error. Okay, so what if we have a binomial with a little 2 there, binomial squared. A lot of times people will try to distribute that exponent over addition, and that's what I'm saying is not allowed. That is not what a plus b quantity squared is. But I do have a shortcut for you that I like to teach all my students, and I have a name for it. It's called square double square. Okay, so we'll do it the long way first to tackle what this really means and why it's not this, but then I'll show you the shortcut. So when you have x minus 5 quantity squared, remember exponents are repeated multiplication. So x minus 5 quantity squared means x minus 5 times itself, x minus 5. And so if you remember that, you can do this the long way, where I call it double distribute, which would give you x times x, which gives you x squared, and then x times negative 5, which gives you negative 5x. And then because you've got the same exact binomial, you'll have negative 5 times x, which is also negative 5x, and then negative 5 times itself, which is positive 25. And so just like before, because you have the same variables, your outer and inner terms are going to be like terms, so you add negative 5x plus a negative 5x is a negative 10x plus 25. So you can see that this is not x squared plus 25. That's what some people try to do. It's x squared minus 10x plus 25. Okay, now here's the shortcut. Because the same thing is going to happen every time, because you're going to have the same exact x here and x there and the same exact minus 5 here and minus 5 there, then the shortcut is just to know that this x is going to multiply by itself. Well, that's another way of saying that is it's going to be squared. So you look at this binomial and say, okay, let me square that x. That's x squared. Now, the middle term, this minus 10, comes from the fact that you multiply this x times this negative 5 and you get negative 5x. But there's always going to be 2 of them, so you double that, which means you multiply that by 2. So 2 times negative 5x is negative 10x. So that's square, double, and then the last term is always going to be minus 5 times minus 5. Well, another way of saying that is you square the negative 5, and that becomes a positive 25. So square, double, square. So you can do it the long way, and if you do it the long way enough, eventually your brain will be like, I think I kind of know what's going to happen before it happens. All right, so let's try this one. And we can do it the long way because it means 3x plus 6 times 3x plus 6. But I'm going to show you, you can pause it and do it the long way. I'm going to show you the shortcut, square, double, square. So when you have a binomial squared, then you just take this first term and you square it. Now, 3x squared, that's 2 because it's squaring the whole thing. It actually belongs to both the 3 and the x squared. So 3x quantity squared is how you say that, would be 9x squared. Then you multiply these two together. Put a little hat right here. And that's 18x. But you know there's always going to be 2 of them. So if you double 18x, that's positive 36x. And then you square the 6. That's 36. And that's what you would get if you multiplied that out. And it works every time. So if you have a binomial squared, then you're going to square that 2x. That's 4x squared. You're going to multiply 2x times the negative 5y, which is negative 10xy. Double that. That just means you multiply the coefficient by 2. So that's negative 20xy. And then if you square that negative 5y, that's positive 25y squared. So it's kind of a quick little easy way to multiply a binomial that's been squared. Okay, if we try this one, when we square this negative x, see, negative x times negative x is positive x squared. When you square something, it always turns positive. And then double, that means you multiply these two together. So negative 1x times 4 is negative 4x. If you double that, that's negative 8x. And then when you square that positive 4, you get positive 16. So there you go. All right, now we'll get to the last two examples. We can multiply any size polynomial to any other size polynomial. So it's not always going to be a binomial times a binomial. And this is why I don't like to think of FOIL. I like to think of double distribute when I have a binomial times a binomial. And it's the same thing here. If I've got binomial times a trinomial, I'm going to distribute this 4a to those three terms, and then I'm going to turn around and distribute this 2 to those three terms. So it's still double distributing. All right, now this is descending order and this is descending order. So I got a little trick to kind of make this a little easier. So I'm going to multiply 4a times 6a squared. First of all, remember that's 4a to the 1, so that's 24a cubed. Then 4a to the 1 times a negative 1a would be negative 4a to the 2. Remember, you're multiplying. And then 4a times 2 is 8a. So I've fully distributed the 4a to the 1. And now I'm going to distribute the 2, but instead of writing it out here, because it's in descending order, when I multiply this 2 times 6a squared, it's going to give me 12a squared. So I'm going to just move over 1 and do it underneath. And you see how the like terms get lined up? That's a little trick. And then 2 times negative 1a is negative 2a. And then 2 times 2 is positive 4. So now it's time to add like terms. So that's 24a cubed plus 8a squared plus 6a plus 4. You should pause the video and try that one. If you did, you should have double distributed. So that would be 7k cubed minus 14k squared plus 21k. And then distributing the negative 3 would give you negative 3k squared plus 6k, because a negative 3 times a negative 2 is a positive 6k. Negative 3 times positive 3 is negative 9. So then you add like terms, and that gives you 7k cubed minus 17k squared plus 27k minus 9. And again, these were not equations, these were all expressions, so we are just simplifying. So when we're multiplying, we have to multiply first and then add like terms. Okay,